Okay, so number 7 is a square root function that we're trying to graph. We've got 3 halves out front, which makes that a vertical stretch because 3 halves is 1.5. A vertical stretch by a factor of 3 halves. We've got plus 6 on the interior with nothing in front of the x, so that is just a left 6, and then a plus 2, which means up 2. So I'm going to go left 6 up 2, and that's my starting point of my quadratic, or of my square root. So left 6 up 2, and then I'm going to use the pattern for a square root, which is, just think, what can we take the square root of? The square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So you got square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. And it's a vertical stretch by 3 halves, which is 1.5. So if I multiply the heights by 1.5, I get 1.5. I get 3, and I get 4.5. The next one would be 16 and up 4, but I don't think, let's see. It goes over 9, not 10. If it was, then we could go up that. As it is, we just graph these points. So I'm going to go over 1 and up 1.5. I'm going to go over 4 from the center point still and up 3. So 1, 2, 3, 4, 1, 2, 3. I'm going to go to the right 9 from negative 6, that puts me at positive 3, and up 4.5 from 2 is 6.5. And that is my original square root curve. So we connect them. And then I've got my domain and range. So my domain and my range. Domain is from negative 6 to infinity. And my range is from 2 to infinity. Which means, for this being f of x, I already know the domain and range of my inverse, right? So I know that my inverse domain is going to be 2 to infinity, and my inverse range is going to be negative 6 to infinity. So, let's go ahead and find the inverse. We switch x and y. X equals 3 halves the square root of y plus 6 plus 2. I'm going to solve for x. I'm going to subtract 2 first. Then we're going to multiply by 2/3 to undo that multiplication by 3 halves. I'm going to remember to multiply both terms by that. So I'm going to leave it as 2/3 times the quantity x minus 2 to make it easier to see my transformations. I'm going to square both sides. When I square, I get 2/3 x minus 2 quantity squared equals y plus 6. And the last step we're going to do is subtract the 6 over. So f inverse equals 2/3 times x minus 2. Oh, I'm sorry, you couldn't see that last part. Quantity squared minus 6, comma. Bye! So the fact of the matter is that it can't be the whole quadratic because my original function was only half of a sideways quadratic, right, or sideways parabola. So you can just remember that this right here tells me what my domain restriction is. X has got to be greater than or equal to 2. And that makes sense if you think about you've got a quadratic shifted to the left, or sorry, to the right 2, down 6. So I've got a quadratic like this, and I'm trying to think which one is the reflection of this piece, and it's going to be this right side. That's going to be the reflection of that across the diagonal. So remember, if you've got your domain of your inverse, then you can go ahead and use that to write your domain restriction. So if I sketch it, I could go ahead and use my quadratic pattern. Only the right side of it though, right? So 1, 1, the 1 squared is 1, 2 squared is 4, 3 squared is 9. And then remember that it's a horizontal stretch by a factor of 3 halves. So I guess I need to label those. Horizontal stretch by a factor of 3 halves, right 2, and down 6. So if I multiply the the horizontals by 3 halves, and remember, I mean, I didn't work it out right here, but if you multiply 1 times 3 halves, you get 3 halves, which is 1.5. If you multiply 2 times 3 halves, the 2's simplify each other out. It leaves you with just 3. And if you multiply 3 times 3 halves, you get 9 halves, which is 4.5. So I'm going to go to the right 1.5 and up 1 from my center point, which is to the right 2, down 6. So right 1.5 up 1. I'm going to go right 3 up 4. 1, 2, 3 up 1, 2, 3, 4. And I'm going to go to the right 4.5 and up 9. So 4.5 from 2 is 6.5. And up 9 from negative 6 is positive 3. And let's see if that matches. So I've got 6.5, 3, 3, 6.5. 5, negative 2, negative 2, 5. Good. 3.5, negative 5, negative 5, 3.5. Okay. So my points match. And let me make those a little bit more emphasized. So just make sure we can see where they are. Okay. So I've got my function and my inverse, and they are reflections across the diagonal. Okay. All right. So the biggest thing is going to remember that your inverse has to have that domain restriction, because your inverse is not a full quadratic; it's only half a quadratic. So let's look at number 8. So for number 8, we've got a square root again, but this time it's got that negative on the interior, which implies there's a reflection, right? In fact, anytime you have something in front of the x, you have to factor it out in order to see the transformation. So it's negative x. Ugh, that was bad. Negative parentheses x minus 5. So if I factor out a negative, that becomes x minus 5. And then minus 3. So the negative is a flip over the y. The minus 5 in the interior means go right 5, and the minus 3 means go down 3. So we're going to go right 5, down 3. Right 5, down 3, and I know that that's my starting point of my original, right? And then I'm going to think about what my function looks like. So normally a square root looks like this, but when I flip it over the y-axis, it's going to look like this. So we're dealing with this situation. So from my center point, it's going to go out that way. Cool? Because technically we flip it and then we shift it to the right 5 and down 3. Okay, so if I use my pattern, it is over 1 up 1, and we're doing the square root, right? So square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, and I can't see 16, so we're good. So there's no vertical stretch or compression or anything like that, horizontal stretch or compression, which is kind of nice. Which means all we do is to go left 1 up 1, left 4 up 2, and left 9 up 3. So I'm at 5, so negative 4 up 3 puts me at 0. Okay. So I'm going to go ahead and connect these. Draw an arrow. Okay, and I'm going to go ahead and label my domain and range. This is f. So for f of x, my domain and my range. Domain is how far left and right. The function goes in negative infinity, and the farthest to the right it goes is 5. Okay. As far as range, the lowest it goes is negative 3, and then it goes up to infinity. Okay. So in terms of my inverse, my inverse's domain is going to have to be negative 3 to infinity, which already tells me my domain restriction. And then range is going to have to be negative infinity up to 5. Okay, so let's find our inverse. We've got x equals square root of negative y plus 5 minus 3. We're going to add the 3 over. We're going to square both sides. So I've got x plus 3 quantity squared equals negative y plus 5. I'm going to subtract the 5 over. X plus 3 quantity squared minus 5 equals negative y. And then we're going to divide by a negative. When you divide by a negative, remember you're dividing everything by a negative, which means this entire term and this term. That does not mean that we distribute the negative to the interior. It means that the coefficient out front, 1, is now negative. So it's negative x plus 3 quantity squared plus 5 equals f inverse, comma, right? Because it can't be a full quadratic because we only started with half of a parabola, half of a sideways parabola. So my domain restriction is this right here. X has got to be greater than or equal to negative 3. I know it's greater than or equal to because it says from negative 3 to infinity, right? If it had said negative infinity to negative 3, then I would have said x is less than or equal to negative 3. But as it is, here's my inverse. Okay? Then we need to state the transformations. So the negative out front is a flip over the x. The minus 3 on the interior means go left 3, and the plus 5 means go up 5. So if I were to sketch my inverse, remember that I've got a quadratic. I flipped it over, and I'm only using the right-hand side. Cool? So I took my quadratic, yeah, I flipped it over, and then I'm only using the right-hand side. Now, it does say x is greater than or equal to negative 3 because it's been shifted, right? So I'm going to go left 3 up 5, left 3 up 5, and I'll just go ahead and plot these points and see if they match our pattern, okay? This is 4, negative 2, so I'm going to go negative 2, 4. This is 1, negative 1, so I'm going to go negative 1, 1. This is negative 4, 0, so I'm going to go 0, negative 4. And so if this mimics a quadratic, so I go over 1, down 1, 2 squared is 4, and 3 squared is 9. Over 1, down 1, over 2, down 4, over 3, down 9, then we're good. Domain from negative 3 to infinity, I agree. Range, lowest it goes to negative infinity, goes up to 5. I agree. And that does look like a reflection across the diagonal. Okay, so that's number 7 and number 8. Let's do number 9 and number 10 right quick. So on this, you're supposed to write down your function given the transformations. So let's write down f of x equals. I'm going to put 2 and I'm going to put it in sub parentheses, okay? Knowing that anything that happens to the interior to x happens inside the set of parentheses and everything else happens in the exterior, okay? So horizontally compressed by a factor of 2/5. That means I'm going to put a 5/2 in front of a set of parentheses with x. I don't know if I'm going left or right, but I do know that much. I guess I'll change my color on that. So opposite on the interior, you got to multiply by the reciprocal. Reflected over the x-axis means a negative out front. Okay, I don't know if I've got anything out here, so I'm just going to leave it like that. But then I do, it says vertically stretched by a factor of 8, so that's a multiplying. So I'm going to put a times right there, make sure we keep those separate. And then shifted to the left 4 units, so that's where I've got an x, and left means plus 4. So my final answer is going to be f of x equals, you cannot multiply negative 8 and 2, because negative 8 is not being raised all the way to power like 2 is. So negative 8 times 2 to the 5/2 x plus, and then 5/2 times 4, 4 divided by 2 is 2, 5 times 2 is 10. And that would be my final answer. Okay, I've got the function f of x equals the 5th root of x, so I'm going to go ahead and put my x down there. So anything that horizontal stretch compression, flip over the y goes out here, shift to left and right, up and down, vertical stretch compression, flip over the x, all that goes there. So reflected over the y-axis, that's going to be a negative. Vertically compressed by a factor of 4/5, that's a 4/5 out front. Shifted to the left 5 units means plus 5 on the interior. Up 16 units means plus 16 on the exterior. And horizontally stretched by a factor of 6 means multiply by 1/6 on the interior. So my final answer is going to be 4/5, the 5th root of negative 1/6 x minus 5/6 plus 16. And there we go.